Hi everyone, welcome to lesson 1.6 where we're going to review solving systems of equations using substitution. So just to review, in order to solve by substitution, you want to start with a few steps. Number one, label the equations. I usually like to start with labeling them 1 and 2. Isolate for one variable and then substitute that variable into the other equation. You solve for the remaining variable, and then you substitute that back into one of the first equations. It actually doesn't matter which one you use in order to find the second coordinate. All right, so let's take a look at example 1, where we're going to solve this linear system using substitution. So what you can see here is that the very first equation is solved for y, meaning that y is equal to 3x minus 5. So I'm going to call this equation 1. And then my next equation is 2x plus y equals 15. And I'm going to call this equation number 2. Now that's just to help me stay organized. So what I write down here underneath is that I'm going to sub number 1 into equation 2. And whenever I do substitution, I want to remember to use brackets just to keep things organized. So here I have, I'll rewrite number 2, 2x plus, and in brackets, I'm going to put that expression for y. So 3x minus 5. And that's going to equal 15. It's just an addition in front of my brackets, so I'm just going to clear out the brackets, and then I'm going to combine my like terms. So if I have 2x plus 3x, I'm going to have 5x minus 5 equals 15. I'm going to take my minus 5 over to the other side, and I'll have 5x equals 20. And then I'll divide this through by 5, and I'll end up with x equals 4. So I've solved for one variable x, and now I'm going to substitute that into one of the original equations. And it doesn't matter which one. I try to pick one that looks pretty easy to sub and work with, smaller numbers. But I'm going to stay organized here. I'm going to write sub into, this time I'm going to pick number 1. So I'm going to go back to the top just for space. And number 1 was y equals 3x minus 5. And since I've solved for x, I'm going to keep the 3. I'm going to use brackets and substitute the value of x. Subtract the 5. Simplifying here, 3 times 4 is 12, minus 5, x equals 7. So this is the solution for this system of equations. And remember, what this is it represents two lines that are on the same graph. A system of equations is a system that has two or more lines on a single set of axes. So this point of intersection, sorry, let me erase that. So the point of intersection of these lines occurs at the point 4, 7. And that's my solution for this particular system. So let's go ahead and take a look at example B. And you can see again that in the first equation, it is solved for x, and x is equal to 4y plus 2. Again, I'm going to name this equation number 1. And then 3x minus 12y equal to 10. That is my second equation. So what I'll do here is I'll sub the first equation into the second equation. Substituting and using brackets, 3 times 4y plus 2 minus 12y equals 10. So that's equation 2 with the substitution included. In this case, I have a 3 to distribute into the brackets. So 3 times 4y will give me 12y. 3 times 2 is 6, a positive 6, minus 12y equals 10. When I take a close look here, I have a positive 12y there. I have a negative 12y there. So they actually cancel. What I'm left with is 6 equals 10. Well, that is actually not true, right? When can 6 ever equal 10? It just doesn't. So in this case, because we get a funny answer like this where it's actually not true, there is no solution for this system of equations, meaning that the two lines on the graph will never actually cross each other. So there's no solution. All right, let's take a look at C. So here we don't actually have one of the equations solved for a particular variable. The first one is 2x plus y equals 1. The second one is 3x minus 2y equals 12. But what I do notice is that there is a single y in the first equation. So what I'm going to do before I start is I'm going to rearrange that first equation and I'm going to solve for y. So here y is going to equal negative 2x plus 1. So I took that 2x over to the right side and it became negative. That is now what I will name equation 1. And then I have equation 2 that I didn't do any manipulation to. So again, I'm going to stay organized. I'm going to sub equation 1 into equation 2, and I'm going to use my brackets. So 3 times x minus 2, and instead of y, I substitute negative 2x plus 1 equals 12. I have to distribute this negative 2 out here into the brackets to clear the brackets. So I'll have 3x plus 4x minus 2 equals 12. Keep simplifying here. We'll have 3x plus 4x is 7x. And I'm going to take that negative 2 over to the other side on the right side, and I will end up with 14. Solving for x here, you'll get x equals 2. And what am I going to do that? I'm going to sub this into equation 1. So y is equal to negative 2. I'm going to sub my value of 2 in there, plus 1. Y is equal to negative 2 times 2 is negative 4, plus 1, negative 3. So the solution for this set of linear equations is going to be 2, negative 3. Okay, so this is all we'll do as far as practicing solving systems by substitution. Take a look at your worksheet. Again, if you have any difficulty with that or you need additional reminders or practice, reach out to me. But I'm hoping that this worksheet for lesson 1.6 is pretty straightforward.